In today's lesson, we're going to solve systems of equations, but we get to choose which method to use. So sometimes it's better to use substitution, sometimes it's better to use elimination. It kind of depends on how the systems are set up, and that's what we're going to go over today. So once you solve, you got to explain which method you used and why. So we'll do that, and then along with that, we have some review problems on finding xy intercepts, and then part 2 of the lesson will be over a couple word problems that we'll be able to experience as well. So looking at this first one, I see y's and x's, equal signs, and constants are all lined up. This is a great one for the elimination method, mainly because of how the equations are set up. Their x's, y's, and equal signs and constants are in line. But I can't just add them together right now because I can't cancel out the x's, can't cancel out the y's. And so I'm going to look at canceling out the x's because all I have to do is multiply that first equation by 4. And that will make it a negative 4x. And then I also have a positive 8y. And this all equals 12. So now I'm able to add those equations together, and I get the x's to cancel out. So once those are gone, I go ahead and add these two terms up. That makes a positive 3y because, remember, they're opposite signs, so I subtracted. And this all equals positive 9. Again, opposite signs, so I subtracted. So just one step there to solve for y, and that is to divide by 3. And we've got our value of y. So in this case, y equals 3. Once you've got that, you substitute that 3 back in for y. Now I'm going to choose that top equation before we modified it. So remember, it was the opposite of x, or negative x, plus 2y. But in place of y, we're putting that 3 in place of y, because that's what y is. And this all equals 3. So we go ahead and do some work. We've got a negative x. We can multiply, and we get a positive 6, all equals 3. And then from there we can subtract that 6 from all sides. And that will give us x, but we've got a minus sign in x in front of the x. So it's negative x equals negative 3. So all you have to do from this point is just divide by that negative 1. So when you do that, that'll cancel out the negative signs, leaving us just with x by itself. So x equals positive 3. So there's our answer. It's going to be an ordered pair, 3, 3. So again, I used the elimination method, and so elimination was the method that I used, and the reasoning was that the terms were lined up. X's, y's, equal signs, constants, those were all in line. So when they are, that's when I use elimination. Looking at the next one, though, I'm going to use substitution. And look, x equals 4y minus plus 2. So I'm going to take that 4y plus 2 and just put it in place of that x. That's the quicker method this time because I don't have the x's, y's, and constants all lined up, and equal signs. So I go ahead and do that, and I've got a 3y and a plus, but in place of x, I'm going to put the expression x is 4y plus 2, and this all equals 10. So from that point, we can go ahead and collect some like terms and then move a term over. So I'm going to subtract that 2 from all sides, and then also collect these 2 as well. And so now I'm left with a 7y equals 8. And on this lesson, it seems as though, oh no, I'm doing it wrong because 7 doesn't go into 8. Well, that's just the way these problems are. A lot of these answers are going to end up being fractions or mixed numbers. And if they are, just leave them as the mixed numbers. So I'm going to leave this as y equals 8/7. The reason is that when you go ahead and substitute back in, you're going to have an improper fraction anyhow. So again, leave them as improper fractions. And so we'll go with x equaling, now I'm going to take that 8/7, put it back in for y. So I'm going to write down 4 times by 8/7, and then this plus 2 as well. And so again, these don't quite go in. There's no cross canceling, so it's just as difficult numbers to deal with. X equals 32/7, and then plus 2. Now I'm going to treat 2 as a fraction. I'm going to multiply it by 7/7. So that makes 14/7. See, 14 over 7 is 2. And this way I can add them together because now they have the same denominator. So x equals, and then I add that stuff, and that makes a 46/7. So there's my answer. I'll rewrite that in as an ordered pair, 46/7, comma, 8/7. So you'll see problems like that on tonight's homework as well, where they just don't quite make the nice clean numbers we're used to seeing. Well, again, we use substitution, and so I substituted, and the reason was that a variable was all by itself. X equaled an expression. And so when x equals or y equals some expression, substitution's the method to use. Different method here. Here we have x's, y's, constants lined up. It's best to use elimination. See, I can multiply this top equation by -2. Every number on that top equation by -2. And what it'll give me is an equation that I'll be able to add together with the second one, and it'll cancel out my x's. I get -4x when I do 2x times -2. -12y, and this all equals -24. So I can add this stuff together, getting these x's to cancel out, leaving me with, and then I just do that subtraction because they're opposite in sign, -7y equals. Now again, if you're unsure, put that bigger number on top and do the subtraction this way. That way you won't make the error of subtracting incorrectly. And so here we end up with 9. So it's -9 because I have more negatives than positives. So we just have the one step there. Divide by -7, and we'll have our value of y. Again, as I said before, on this assignment, these problems that are set up as systems for you to directly solve, a lot of them are coming up as these improper fractions. Just leave them like that. Don't change into mixed numbers. Leave them as improper fractions and just deal with it. So y goes, this 9/7 is going to go in for y. I'm going to put it into that equation right there. So it's 2x plus 6 times by 9/7. Think of this as like 6 over 1. And so you can see the multiplying that's going to end up happening here. We don't have any cross-canceling, just got to deal with it. 2x plus, and this makes 54/7 equals 12. Well, you know you have to subtract. So when you subtract, same thing as adding, you got to come up with that common denominator. So I'm going to subtract that 54/7. I'll write down the 54/7 right here. And I got to subtract that as well. So I'm going to rewrite this. I'm going to multiply it by 7/7. That makes 84/7. 84 is 7 times 12. And then I'm subtracting the numerators. So what's left over? Well, I've got 2x equals, and then I subtract that, and I end up with 37. So now I'm ready to multiply by the reciprocal. Anytime I've got to deal with fractions and multiplying, I'm not going to divide by 2. It's the same thing as multiplying by the reciprocal. So I'm going to multiply by 1/2. Treat that as 2 over 1. Get those 2's to cancel out. Do the same thing over here. And so you just multiply across. A little bit of cross-canceling here. Look at that 2. It goes into 30 15 times. So we've got x equals 15/7. So there it is. Our answer was a little bit tougher. Dealt with some fractions, 15/7 and 9/7. So it's always good to be able to manipulate fractions quickly. It makes life problems like this a lot easier. So anyhow, again, you're going to have to deal with some fractions. Just one of those things. And also, we got to explain which method we used. In this case, we used elimination. And the reasoning for that was that we had x's, y's, equal signs, constants. They're all in line. Well, the last problem that we're going to end up having to deal with, on the bottom of the page, you will have some word problems, and we'll get to that in the second part. But on page 342, they ask you to find some intercepts. So remember, it's just a review, no graphing here, just find the intercepts. So the intercepts are where they cross the x and y axes. So remember, for that x-intercept, you're going to end up setting y equal to 0. So you're going to cancel out this y term, and so all you're left with is 1/2 x equals 6. So remember, you eliminate that. You don't even write it down. You just write down the x in the 6th term. the constant in this case. And so from there, it's just a matter of one step here. Multiply by the reciprocal. Multiply by that 2. Do the same thing on the other side, and you see you don't get a fraction. You get x equals 12. And so that is the x-intercept. Again, you can write that as an ordered pair, and that would go 12, 0. Well, for the y-intercept, we're going to do a similar thing. We're going to set x equal to 0 for that y-intercept. Now, when you do that, it cancels out your x term, so all you're left with is that negative 3y equals 6. So a common mistake I still see is people forgetting to bring down the minus sign with the term. So you just got to be really careful as you do these problems. Negative 3 is what you're dividing by, and you've got yourselves y equals negative 2. So there's your answer. You just can write that as an ordered pair. Sometimes they're written that way on multiple choice tests. So 0 is x, y is negative 2. Well, one more problem, or your last problem, number 48, is similar to this one. You see, you don't have x and y on the same side. And when you don't have them on the same side, the common mistake is people get the x-intercept right, but the y-intercept, they're going to make a sign error, because you'll end up dividing when you really need to do an opposite operation. You don't divide or multiply unless you have the variable by itself. So that's what I want to do first. I want to move this y term over to the other side. I'm going to subtract it from both sides. You always want to have the variables on one side, constant on the other side. And so that's a 10x, and it's a minus 5y. So now we're ready to use intercepts. So you do the same thing you did before. You find your x-intercept, and so when you do that, you're going to set y equal to 0. And so we go ahead and cancel out our y term. All you're left with is that negative 40 equals 10x. You do that division, and you end up with negative 4 as x. So you can write that as an ordered pair, negative 4, 0. The last part, y-intercept. Again, you're going to now set x equal to 0. When you do that, your x term cancels out. So now you have negative 40 equals negative 5y. Again, you see in the original problem, you can't do the division until you get the variable by itself. Now when you do the division, you get 8, positive 8 for y. And so your answer is 0, 8. So there it is, x, y intercepts and solving systems. Next part will be to solve some systems that we are dealing with. Well, we're having to write systems first, solving some word problems with systems.